Welcome to Study Loop.
Hi friends, here it is given a reversible absorption refrigeration cycle consists of reversible heat engine and reversible refrigerator. The rate at which the steam condenses that we have to find. In second part, we have to calculate the power input to reversible refrigerator. Second law, efficiency. Let us start solving it using the property of fluid, enthalpy of vaporization, of water at 150 degrees Celsius is 2113.8 kilojoule per kg as given in table A4. The thermal efficiency of reversible heat engine. Thermal efficiency of reversible heat engine can be defined as 1 minus ambient temperature upon temperature of source. In the problem, ambient temperature is given 25 degrees Celsius, that is 25 plus 273.15 upon temperature of source, that is 150 degrees Celsius. It is given in the problem. So you will get 0.2954. The coefficient of performance of reversible refrigerator temperature of sink upon temperature of ambient minus temperature of junction. In problem, temperature of sink is given minus 15 degrees Celsius, but we have to use in Kelvin. T naught, that is the ambient temperature, is 25 degrees Celsius. So 25 plus 273.15 minus temperature of refrigerated space or sink 273.15. So on solving it, the performance of coefficient of performance of reversible refrigerator we will get 6.454. The coefficient of performance of reversible absorption refrigeration COP of absorption can be defined as efficiency of thermal thermal efficiency of reversible heat engine into coefficient of performance of reversible refrigerator. So it is to be 0.2954 into 6.45, that is 1.906. The heat input to reversible heat engine heat input to a reversible heat engine is this value is given rate of absorption of heat from the refrigerated space. It is given in the problem 70 kilowatt upon coefficient of performance of reversible coefficient of performance of reversible absorption refrigeration 1.906. So it is to be 36.72 kilowatt. The rate at which steam is condensed, the rate at which the steam condenses is rate of heat input upon enthalpy of fluid for vaporization. Substitute the value. You will get 36.72 upon 2113.8, that is 0.017 kg per second. So this is the rate at which steam will condense. Now in second part we have to find the power input to the refrigerator. It is defined as power out from heat engine into power out of heat engine. It is defined as thermal efficiency of reversible heat engine into total power in. So 0.2954 into 36.72, so 10.9 kilowatt. See, the second law efficiency is defined as actual coefficient of performance upon coefficient of performance of reversible absorption refrigeration. This is given 0.8 upon 1.906, that is 0.42 or 42%. And that's all for it. Thanks for watching it.